Right. In this lesson, we derive the trigonometric identities used from the unit circle. So if you have the x and the y axis, right, this is the y axis here, y, this is the x axis. Now, if you have a unit circle within this, a unit circle is a circle that has a radius of 1 unit. So let's define the unit circle along this plane. So let's say we have a circle here, and then this is the center of the circle. So the distance from here to this point, let's say it is 1 unit. So that's what we call it, a unit circle. That's why we call it unit circle. So let's say this is 1 unit. So this circle, it has the x and y coordinates. Okay, so there are x and y components of this. This forms a right angle triangle. So the horizontal component is x, while the vertical component is the y. So this is the angle between them. Let's name the angle theta. So I would like us to transfer this diagram to this side so that we can see it clear. You have this as the angle theta. This is x, this is y, and this is 1. Of course, that's the radius of it. So from what we have here, we can define the trig identities of sine, cos, and tan. Here we can start with sine. You can say that sine of this angle theta, which is opposite all over hypotenuse, and the opposite here is y. Meanwhile, the hypotenuse here is 1. So from what you have here, you have your y. When you cross multiply, your y will be equal to sine of your angle theta. So sine theta will be our y. So let's tag this as our first equation. Then for cos, you have cos theta will now be equal to the adjacent side, which is x, all over the hypotenuse, which is 1. And cross multiplying, you have your x to be equal to cos theta times 1, which is cos theta. So let's say this is our equation 2. So we now have two equations here. So let's consider the tan theta. The tan theta of this angle will be opposite all over the adjacent sides. The opposite side is y, while the adjacent side is x. So we have y all over x. So here we have our tan theta being equal to y all over x. Now let's derive an identity that houses sine, cos, and tan all together. Now you will realize that from equation 1, y is equal to from equation 1, y is equal to sine theta, and then tan theta is y all over x. So let's substitute y here for sine theta, because y is equal to sine theta in equation 1. So tan theta will now be sine theta all over our x. Of equation 2, x is cos theta. So we have here as cos theta. So this is an identity that is very, very important. So if you take note of this, sine tan theta is equal to sine theta all over cos theta. So let's tag this equation 3. Let's tag this equation 3. Of course, it's our first identity, but let's target equation 3. Then we'll now proceed. Now from the diagram, you have, I will draw this here again so that we'll be making reference to it. So you have your theta, you have your x, you have your y, this is 1. Now, this is a right angle triangle. Of course, we can apply Pythagoras theorem. Now, applying Pythagoras theorem to this, you have hypotenuse square, which is 1 square, is equal to x squared plus y squared. So using Pythagoras theorem, we have here as y squared. Let's start with y squared plus x squared will now be equal to 1 squared. So this will be y squared, and from our equation 1, y is sine theta, so this becomes sine square theta plus the x from equation 1 is cos theta, so we have it as cos square theta. If you square cos, you have cos square theta equal to 1 square is 1. So this is identity for, let's say it's our identity 4, or say it's identity 4. Now let's consider tan theta being equal to sine theta all over cos theta. So we use sine square theta plus cos square theta to derive the other identities. So first of all, we'll say that dividing through by sine square theta. So let's divide through by sine square theta. So here we have sine square theta plus cos square theta equal to 1. So we will divide through by sine square theta all over sine square theta all over sine square theta. So in this case, sine square theta divided by sine square theta is 1 plus cos square theta over sine square theta is cot. Why is this so? It's because tan theta is sine theta all over cos theta. Then if you are having cos theta over sine theta, it means that you are taking a reciprocal of tan, and this will be cot theta. So 1 all over tan theta gives us cot theta. That's the reason why this is equal to cot. So it is just the inverse of tan. So here, instead of having tan square theta, it will rather be cot square theta, which is equal to 1 all over sine. Since 1 all over sine theta is equal to cosec theta, you now have 1 over sine square theta will now be cosec square theta. So let's tag this as our fifth identity on the trig ratios. Now, still from sine square theta plus cos square theta, we will now divide through by cos square theta. The first one here, we divided through by sine square theta. So in the next phase, we will divide through by cos square theta. Alright, so I will rewrite this as sine square theta plus cos square theta equal to 1. Then you dividing through by now we divide through by cos square theta. So here you have sine square theta plus cos square theta equal to 1. Divide through by cos square theta all over cos square theta all over cos square theta. So sine over cos is tan. So sine square theta over cos square theta will now be tan square theta plus cos square theta over cos square theta is 1, which is equal to 1 all over cos is sec. So 1 over cos square theta will now be sec square theta. So this is another identity for it. So let's tag this identity 5. Okay, no, let's tag this identity 6. So all in all, we have the fact that tan theta is equal to sine theta over cos theta, We have sine squared theta plus cos squared theta is equal to 1. We have 1 plus cot squared theta equals to cosec squared theta. And also we have tan squared theta plus 1 equal to sec squared theta. There are some other ones, but for now we will stop at this one. If you have any question, you ask in the comment section so that I can attend to you. Thank you.